You need to actually spend some time trying to solve. You can solve this. You can solve it. It's definitely solvable. You understand what it means, right? Have you started going in the right direction? Yeah? Okay.
So if I do all that algebra, will
Y equals sine inverse x means the sine of what angle equals x. That's what it means. That's the definition. We're okay with that? You took trig, everybody, right? We now have the ability to differentiate sine y equals x because we now know how to implicitly differentiate. What's the derivative of sine? Cosine y times what? Prime is going to equal what? 1. Okay. So we have y prime is equal to 1 over cosine what? Cosine y. So at this point you say to yourself, okay, that's interesting. Doesn't seem to help us too much. We'd like to clean that up a little bit. Is there something? Yeah, exactly. Our favorite trig identity is this. Sine squared x plus cosine squared x is equal to 1. So that means that cosine squared x is equal to 1 minus sine squared x. So what does cosine equal? Minus. Okay. Okay with that. Let's just substitute that back in. So what do we know y prime is equal to? 1 over what? Square root of 1 minus sine squared. Sine squared y. It is sine squared y. Because it's the same. You don't change the variable there. Okay, that's interesting. Well, what do you notice right here? What does sine y equal? Sine y equals x. So what do you now have? Y prime is equal to 1 over the square root of 1 minus x squared. Welcome to the first of the 6 inverse trig derivatives. This is the derivative of sine inverse. If y is equal to sine inverse x, this is the derivative of sine inverse. You must memorize all 6 trig derivatives, all such trig, and all 6 inverse trig derivatives. For some reason, I don't know why this is the case. Every time I say that, people are like, oh my god, this is so terrible. I can't do that. How many of you take a language?
I took one.
How many of you have taken a language at this school? Raise your hand high.
Taking 2.
Yeah? Okay, all of you. How many of you have taken a history class? Or some sort of social studies class? Everybody raise their hand. Maybe memorize a little bit more in those classes than you do in this class? Right? So I want to hear absolutely no complaining about this. I'm telling you exactly what you need to memorize in order to succeed in the next portion of this. You can do the rest of these very similarly. Here they are, right here. Can someone, just by briefly looking at those, they're not overly complicated, but can you tell me what the hardest thing, what makes it really challenging to actually memorize these? Can you tell me what makes it hard to memorize these? No, it's not the negative and positive aspects. Although you'll notice that anything that begins with a C is negative. Anything is C is negative. That's great, but can someone tell me what makes it hard to memorize these? Like this one by itself is not that hard. What is it? What is it about all 6 of them? When you look at all 6 of them, what makes it hard to tell them apart? They look really similar, but they are not. These are not complicated equations. They look really similar, so I can guarantee you're going to be cruising like, oh my gosh, is that secant, cosecant, trig? Okay? You must know these cold. Meaning without any hesitation. It's really important because you're going to need to be able to recognize, you're going to be cruising along later in this class or in BC calculus. You're going to be cruising along and all of a sudden you're going to see this right here. And you're like, I have no idea what to do with that. If you remember your inverse trig derivatives, you're going to automatically recognize, oh, that's the derivative of secant inverse. And then all will be well in your universe. Sometimes there are questions where if you don't recognize one of these, you will not be able to the problem at all. There's no way around it at all. You must, in this case, y prime is equal to 1 over 1 plus x minus the square root of 1 plus, oh, messed up that one. 1 plus x squared, what do I do to that? And then I multiply by x minus the square root of 1 plus x squared, but what do I take of that? The derivative of that. So we end up with y prime is equal to 1 over, and you don't need to multiply this bottom one out. This is fine. You can leave it like this. Times 1 minus what? 1 half 1 plus x squared to the times 2x. Leave it like that. That's fine. There's some basic simplification you can do, but at this point, that's fine right there. That shows me you did the process correctly. You could, I mean, you could go, okay, I'm crossing that out like that. You could, you know, my bet is when you square that, it cleans up a little bit, but you don't have to. This is fine right here. This is fine right here. Totally fine. Testing you on calculus right now, not algebra. Okay, any others from this group that you'd like to talk about? Any others from this group that you'd like to talk about? Any? 42? Okay, it's a good one. So what's the outer function? Yeah, the outer function is not tan. The outer function is, so 1 half tan inverse of x to the what power? And we're multiplying by tan inverse x prime. So y prime is equal to 1 half tan inverse to the negative 1 half times what? Could you clean that up a little bit? Absolutely. For example, this could easily be a multiple choice test, a multiple choice question on the AP exam. Absolutely. And they would not leave it like that. They would probably write it as 1 over 2 times 1 plus x squared times they would probably write it as the square root of tan inverse x. They'd probably write it like that as one of the solutions. But then they'd give you 4 others that look really similar to that are not in fact the proper answer. How do we feel about these? Are we decent-ish confident on these? Decent-ish? No, maybe? Yeah. Well, you're going to have some practice.